Today you're going to learn the test-taking strategy for interpreting data tables and experiments. Strategy 1. Interpreting data tables. When you see a data table in a science question, that tells you there is a lot of information that has been organized into one area. The very first thing we do is we look at the title. This title is Properties of 6 Minerals. This gives us information. Information point number 1. The columns will have properties of minerals. We have 1, 2, 3, 4, 5, 6 minerals listed. The properties we have are hardness, density, luster, and streak. As we look at the information in the columns, we look down the hardness column and we see that the hardness scale of each mineral goes from the hardest to the least, which is talc. We see our density is all over the place, so there's no clear pattern within the density. Luster is one of those qualitative properties, and it is just glassy, metallic, and pearly for talc. Streak, we see, are also colors, and that is also qualitative information. When you get a data table in a test question and you look at it, you may want to go on and write some information down. Some of the information I would write down would be that the hardness scale goes from the hardest mineral down to the softest mineral. That is the only clear-cut pattern in this data table. So after you get, let me fix there we go. After you get a data table, you will get a question. Now that we've looked at our different minerals, we look at sample question 1. It says which mineral in the table could be scratched by all of the others. We have A, quartz. So we look and we say, well, quartz hardness is 7. It can be scratched by corundum, but it cannot be scratched by any of the others. We see galena, which is 2.5. Galena can be scratched by many others, but not all the others. Copper hardness is 2.8. It can't be scratched by the other. It can be scratched by these, but not galena or talc. Then we see D is talc. It is only a 1, so anything above it, it can be scratched by. So the correct answer is D, talc. So let's go on to sample question 2. So the question is, suppose you have found a dense, so that's our first clue, dense, so we know we're going to be looking at density, dark colored mineral with a metallic luster. So we know we're going to be looking at these 3 minerals because these 3 minerals are metallic and they have a density, and we're looking at one that is dense. All right, these 3 minerals are denser than the corundum, quartz, and talc. What property could you test quickly and easily to determine if the mineral were copper rather than galena? So we have copper at an 8.9 density and galena at a 7.5. Well, which one of these properties could you test quickly? And if you look, they're about the same hardness, so that may not be a very good test. But if you come over here to streak, if you put your mineral against a streak plate, the streak for copper would be red, galena would be lead gray. So already you know, oh, it must be streak. let's see. Oh, let me go back. If we can find there we go. If we can find the correct answer, we need red. Or we need, I'm sorry, streak, and it is H, and indeed the answer is H. Our next strategy we're going to learn about is how to interpret experiments. Experiments will come with a lot of information, a lot of written information. But if there is a data table, you're going to use the same strategies that you used before to look at your data table first. So before knowing anything about this experiment, we look and we say, oh, number of birds. So we know that this student counted the number of birds on 4 days, and they used 2 different types of bird seed, sunflower seeds and thistle. And we look across the data table and we look down the columns. We see day 1, the birds preferred sunflower seeds to thistle seeds. We see day 2, more birds preferred thistle to sunflower. On day 3, more birds preferred thistle to sunflower, but on day 4, more birds preferred sunflower seeds to thistle seeds. That gives us a lot of information. Again, I would write this information down so you already have it, and the very first thing you do is you look at your data table. Next, let me move my screen down a little bit. I'm not going to read the passage yet because I'm not sure I need the passage yet. I'm going to look at the question, what variable is tested in Rodney's experiment? That's a pretty straightforward question, and I can see that the variable that he tested was the type of bird seed because that's what he was testing. How many birds prefer the type of bird seed? The question is the number of birds. That is your dependent variable. That is not what he tested. The type of seed, the day, the type of feeder. The type of feeder is not even on here, or the type of seed. And we know that it is here. It is always going to be in your data table, the independent variable or your test variable. And we know that it is C, the type of seed. I still have not read the experiment yet. I don't need to yet. Question 2. Based on the data, what conclusion can Rodney draw? Okay, this can be a little tricky because this is asking for a conclusion. Again, though, you've written down the information. We went through and we said, well, on days 1 and 4, the birds preferred sunflower seeds. On days 2 and 3, the birds preferred thistle seeds. I'm not real sure what the conclusion can be. There's nothing that is definitive in this experiment. So let's read our answers. F, the birds in the neighborhood prefer thistle to sunflower seeds. We can't say that because there are 2 days in which the birds preferred sunflower seeds. G, the birds in the neighborhood prefer sunflower seeds to thistle. Again, we cannot say that because there are 2 days that the birds preferred thistle seeds. H, the birds in the neighborhood show no clear preference. I'm going to keep that one on my back burner because that's really what I think, but I want to read the last one to be sure. J, the birds in the neighborhood are unlike most other birds. The experiment has nothing to do that. That's your answer that you throw out because that's your crazy answer. So indeed, it is H. The birds in the neighborhood show no clear preference. Now that we've gone over a couple of your test-taking strategies for interpreting data tables and experiments, you're going to have an activity that you're going to do next where you're going to practice. Good luck!